What? Sabine Hossenfelder recently posted a video about small modular reactors coming to Europe, but specifically thorium-powered reactors. That got my attention, and here I am to react to this video and let you know all about my perspective as a nuclear physicist on it. Without further ado, let's get into it. I already like from the thumbnail that usually people, when they talk about thorium reactors, they put the thorium sign there because there isn't really much to put in terms of pictures or designs or layouts. You could put like a diagram or something, but nothing really built to be used like this. Thumbnail says nuclear power, yes please, and sure, I can agree to that. However, nuclear power, yes please / nuclear power by thorium is a whole another discussion. We have had a video about thorium powered reactors and their advantages and disadvantages in the past, so you can go check it out. But let's see what Sabine has to say.
Phasing out nuclear power is the dumbest thing the Germans have ever done.
Well, with that, everybody can agree. I really like how she starts the video straight on by saying that the probably biggest mistake of Germany as a country was the fact that they just shut down all their power plants and stopped generating energy by nuclear energy, and they didn't really have the backup solution on that, and that was basically the biggest problem. Because it's not so much so as to if a country decides not to use nuclear power, but they have a very good alternative or mix of energies that could supplement the same amount of power that they require or electricity that they require without the need of nuclear. But when you don't have that and you have a very dense energy source such as nuclear and you decide in a day to shut that down, and then when you're asked, okay, but what's your alternative? You don't really have one. There's a little bit problem over there. So I'm glad that she calls out also her own country. It couldn't be the easiest thing to do, but scientifically speaking, politically speaking, and logically speaking, the decision was not the wisest.
When I say this on Twitter, people come and tell me that Hitler did a few things that were even dumber. I disagree. Hitler wasn't dumb, he was evil. He knew full well what he was doing. I'm not at all sure the current German government knows what it's doing, and that isn't a good thing either. The German opposition to nuclear power is especially curious as our next-door neighbors, the French and Dutch, have no hesitation to use nuclear power to its full potential.
And especially France, since this is the country in Europe with the most use of nuclear power to produce electricity. And neighboring that country, even in terms of fearing a potential outlandish accident, it would affect the neighboring country, such as Germany. Nevertheless, even if you are a country that doesn't use nuclear power, but is in need of energy and buys electricity from countries that produce electricity by nuclear power, do you see the problem?
Potential. Indeed, companies in both countries recently teamed up to bring small thorium reactors to Europe. Let's have a look at what's new. The news is that two companies, Narea of France and Thorizon of the Netherlands, have signed a partnership agreement to work on thorium-fueled small nuclear reactors.
I'm quite curious as to why was the choice thorium reactors. It is of an interesting question to ask, since if you remember, the biggest kind of drawback with the thorium is the fact that you can actually separate those isotopes that are used for proliferation reasons to make nuclear bombs. So for a country that has nuclear weapons, there is a potential or maybe an interest there, but for countries that don't, I have a really hard time seeing how they will move forward with a reactor design as such, with this kind of inherent feature, since they don't have a license or any way of proving that they will not use these separated isotopes for other reasons.
Thorizon, as the name indicates, specializes in using thorium as nuclear fuel. Narea is already working on.
I don't know these websites and companies, so I really want to check. Thorizon.
What about climate change? Use salt as base for both fuel and coolant. Modern salt has several benefits. First is that you have a processing and recycling existing radioactive waste. our reactor does become a waste burner, reducing the amount of radioactive waste.
It is quite interesting how this is always put forward as an advantage. It is an advantage, it's just a little bit hard to grasp. Since the fuel is already molten, there is no potential for core melt, since the fuel is already melted.
Also, the salt can handle very high temperatures, atmospheric pressure, making safety measures less costly than with traditional reactors. Lastly, there is no water used in the reactor. This means past accidents resulting in the release of radioactive materials are no longer possible.
So, Narea now. Carbon-free decarbonized energy.
Narea Nuclear Abundant Affordable Resourceful Energy for All is a French company. Okay, also a French company. One that is decentralized and can be installed close to industrial consumers and in remote areas.
Okay, this all makes sense. And if both of these companies are basically French, then the potential of them developing thorium-powered reactors is actually viable. Let's see.
Netherlands have signed a partnership agreement to work on thorium-fueled small nuclear reactors. Thorizon, as the name indicates, specializes in using thorium as nuclear fuel. Narea is already working on small nuclear reactors, and they want to combine their technology with the thorium cores from the Dutch. In case you're wondering what their logo is supposed to show, that's a radish. Yes, a radish. Because as they explain on the website, the radish is a root vegetable that leaves no waste as the entire plant is edible.
So is this their way of showing that they will not leave any waste because they're basically going to burn the waste from the nuclear industry that currently is producing it? That's kind of cute. I can get behind that.
The idea is that rather than building one huge and expensive nuclear plant at location, you build smaller reactors that can then be transported to the place you want them.
So the difference between in size in terms of small modular reactors, SMRs, and the ones we have been building so far, the typical light water reactors, is the fact that, as Sabine also mentioned, the light water reactors that were built so far have literally been built on the site that they were decided that the nuclear power plant will be. So the building and everything is being built on site, the reactor vessel, the building around it. So it is a huge construction, and it is several buildings big for it to fit all of these components and all of these parts that need for the reactor to work and produce electricity. However, the SMR, small modular reactor, it is quite big in a sense that it's not really small. Is basically relative, right? Is small relatively to the reactors that we have been building so far, but not small relatively to, I don't know, a kitchen table. So in that sense, a small modular reactor can still fit into a room, like a quite big, tall room. And as Sabine says, can be transported by a truck, basically. And it will be approximately around 1/3 of the power output of the light water reactors that we're currently using. And modular does mean made in the factory, shipped around the world and installed. This is a great advantage because you don't need to even own the technology or know how to make this kind of reactors in order to use them. You can basically buy them from companies and install them in countries that need them or in industries that require additional energy. And reactors are still standing for the fact that these reactors will use energy by fission to produce power and consequently electricity and the like and the like.
Small modular reactors have the potential to solve the two biggest problems of nuclear power at the moment, which is that building nuclear power plants is expensive and it takes a long time.
I agree.
Though if the small modular reactors will actually solve those problems, only time will tell.
So it's a little bit of a tricky situation there as well, because small modular reactors haven't been built yet in a kind of streamlined production process. Therefore, when we start building small modular reactors, it is estimated that they will cost more than the light water reactors that we already kind of know how to build, and there is some experience there. But the idea with the SMRs is that the more you build, the cheaper they become. Basically like any other product. When you make the first one, the first of a kind, it will be expensive and there will be some back and forth in terms of fixing some stuff. But once you have streamlined the process, similarly to take aviation industry, you know how to make a particular type of plane, and then you just keep making it, and it becomes cheaper and cheaper the least intervention you need to do in the process of fabrication.
Two companies who have signed the new agreement say that they want to cater in particular to the industry, where such a reactor wouldn't be connected to the public electric grid. You can also use the heat from the reactor directly rather than making electricity from it first, which improves efficiency.
So there's great flexibility, like Sabine mentioned already, with the small modular reactors, and this is the fact that since they are small and kind of compact and flexible in terms of power output, you can really install them in industries that are very energy demanding. So you can help the industries produce more electricity for making whatever products or services they are making, and therefore not being so reliant or heavily reliant on the grid. And on the other hand, small modular reactors, depending on what type of reactor it is, can also be used for direct heating. So it can be used for hydrogen production, production of biofuel, and this is mostly for the fact that these reactors will run on higher temperatures than the light water reactors that we have so far. But that is a little bit of a confusion, because small modular reactor doesn't necessarily mean that. A small modular reactor can be a light water reactor as well, and can be a reactor that doesn't run at the temperature that's high enough to be efficient to produce this hydrogen and biofuels and the like. But if it is a small modular reactor coupled with a Generation 4 design, then this potential can be harnessed. And that is because to have higher temperatures, you require coolant that is not water. So for example, in terms of lead-cooled fast reactors, then you would have an output temperature in the reactor of around 550 degrees Celsius, and this is higher than the output temperature of a light water reactor. Therefore, there the potential is possible. So SMR and Gen 4 sometimes is a little bit intermixed. When we talk, we assume that an SMR is a Gen 4 and vice versa. It is not necessarily the case. An SMR, a small modular reactor, can still be a light water reactor, just in a smaller size.
What they call an extra small nuclear reactor that'll generate roughly 40 megawatts of electricity, and they hope it'll be done by 2030. Horizon is working on,
and the hope to be done in the span of the next few years, it's optimistic. Let's see. I haven't heard much from Narea in terms of actually what comes after the research and the paperwork, like in terms of actually starting to build something.
A reactor with roughly 100 megawatts that is targeted at larger industrial customers. They want to have a pilot system ready before 2035.
Okay, so Horizon is aiming for almost double in size, in the range of small modular reactors, or even smaller than that a little bit. And they are aiming to have it ready by 2035. So a little bit of a less optimistic, maybe more realistic approach for them, especially since they are aiming for a little bit of a bigger system. My still kind of question throughout this video that I haven't answered yet to myself is, why use thorium? In a way that France has lots of spent nuclear fuel from its nuclear industry, that it is using and reusing and creating this so-called MOX fuel, mixed oxide fuel, which is a uranium-plutonium fuel that is being burned and kind of recycled in reactors that they have or plan to build. So why make a whole new type of advanced reactor that might have its own kind of challenges, instead of making a reactor that can potentially burn MOX fuel? Or I am still a little bit confused as to where does thorium come into place with the recycled fuel from the France's nuclear industry. Let's see.
Almost all currently operating nuclear reactors run on uranium. Thorium has attracted attention in the past decades as an alternative nuclear fuel because on Earth's crust it's about 3 to 4 times more abundant than uranium. It also can't be as readily used for nuclear weapons, though if you make some effort, that's still possible.
So Sabine mentioned that thorium cannot readily be used as for nuclear weapons, even though with a little bit of effort this is possible. So this statement is correct and incorrect at the same time, in a way that thorium in itself is not interesting for nuclear weapons applications. However, a reactor fueled with thorium is the perfect kind of machine to create isotopes that can be used for nuclear weapons applications. So it's kind of incorrect to separate the two and give thorium the advantage that is not interesting for proliferation, even though knowing that the process with which the reactor that's fueled by thorium operates quite literally creates nuclear weapons grade materials. So I have to give to Sabine of a little bit of a homework as to how thorium reactors work, and maybe an additional statement that explains a little bit more instead of it can be possible. It's not just with a little bit of effort it can be possible, it is actually very much likely, possible, doable, and one of the biggest concerns of the nuclear industry as to why we haven't implemented or heavily got interested in attention into thorium fuel.
The real advantage of thorium reactors is, however, that they can use essentially the entire thorium, not just a small fraction of it, as it's the case with the normal uranium reactors. The downside is that since there's currently no dedicated thorium mining, it might go into short supply quickly, so there are some commercial challenges ahead. The small nuclear thorium reactors work not with solid fuel rods, but with the fuel dissolved into a liquid salt. This is why they're called molten salt reactors. Modern molten salt reactors, as all newer reactors, come with passive safety features. In the case of a loss of power, the nuclear fuel will be automatically dumped into a place where it'll cool, rather than in earlier reactors go on to heat up and potentially cause the core to melt.
So this is the interesting or kind of funny sounding phrase of, since the fuel is already molten, core melt is not really a danger for this type of reactors. So I guess in a way that if there is an accident, that basically the fuel is being drawn somewhere else and freezes and becomes solid. And if it becomes solid, it contains all of the radioactive materials. It's not really spread out. There's no gas coming out of it. So in a way, it's really contained.
That said, nuclear power is still dangerous, and I fully understand that many people are opposed.
That said, nuclear power is still dangerous. Okay, maybe I should watch it and not comment so quickly.
To the technology because of the risk. However,
but so what is the risk? Because we are in the small nuclear thorium reactors video, and there was no risk proposed for the fact that these reactors can produce nuclear weapons materials, and they do if you operate them. But then a big radioactivity sign and saying that, but nuclear energy is still dangerous. And I understand that people are opposed to it, but why? What is the danger that we're talking about? Because the biggest danger is the accident maybe, and you have already explained that the most serious accident that can happen in a molten salt reactor that runs on thorium fuel is the fact that if there is some problem in the vessel, then the fuel will just freeze, so there is no really a danger there. And the second is the spent nuclear fuel and the fact that it will last for thousands and thousands of years, and it will still be radioactive and dangerous, and people might not like the idea of burying it underground. And this solution basically solves that problem because it reuses the fuel from the industry and it burns all the thorium and it will last for so many years. So giving all of these positive kind of advantages of these reactor types and concluding with a sentence of, but nuclear industry is still dangerous and I understand why people oppose it, I don't understand why you would say that, because then it contradicts everything you just said in the previous 6 minutes of your video. So it needs to be a little bit more context and not taken by default that, but people might just not like it, you know?
Everything has risks, and I think one also needs to take into account the risk of not using nuclear power,
right,
because that means continuing to use other sources of energy which also have risks.
So that is the biggest kind of thumbs up I give to Sabine, is the fact that when we always discuss about using nuclear power over renewables or over another source, and maybe we should use that instead of that, the question is not if we should use nuclear power or not, but the question is what should we use to phase out fossil fuel use. So to phase out fossil fuels and stop producing emissions and basically contaminating and destroying the planet, we need to use all the other energies that are friendlier to the environment, more sustainable, renewable, and the like. And those are wind, hydro, nuclear, and everything else that doesn't destroy the environment in a way that fossil fuels do. So nuclear is part of that mix, is a very strong part of that mix, is a very big player because it is the densest energy out of all of them. So when we're discussing the risks of using nuclear power, we should also discuss the risks of not using it. So that I agree with.
Nuclear power technology has changed a lot in the past 50 years, and I really think Germany is missing the bus by not investing into it.
I agree that Germany is definitely missing out. I was chairing a workshop recently in Karlsruhe in Germany, and there we were talking about communication tools on nuclear and nuclear research that the European Commission and the Joint Research Center can implement in order to promote and talk a little bit about their nuclear research in Germany, which was very nice and positive to see. And I was invited to speak there and propose some different ideas that they can use in order to attract a little bit more interest from different kinds of audience, all the way from member states and countries of the European Union and to the public and the people that are interested or work in the industry or just interested to learn about it. So it was a really nice thing to see, and that they are planning things like that and they are planning events like this, and it is important for them to communicate the research in a way. So I really do hope that Germany will change its perspective quite soon and realize the big mistake that everybody else have realized that they have made, and take it back and start working on nuclear again.
So in case you're from the German Parliament, denkt noch mal drüber nach. Thanks for watching. See you tomorrow.
Okay, that was the video of Sabine on small modular thorium nuclear reactors. That's a mouthful. And it was interesting to find out that these two countries are collaborating with each other. From France, it is quite, as I said, understandable pushing this kind of design, because there is not really a limitation or so much so of a problem building this type of reactors. However, them being built in the Netherlands or in any other country that doesn't have nuclear weapons, then that would be a little bit tricky in terms of the country or the regulators accepting this type of reactor to be built there. However, for France, it does sound like a very attractive and interesting solution in terms of research, at least as it is in this stage right now, because I'm assuming they have not started building anything yet. And I'm glad to see that Sabine is bringing up nuclear news and just things that are happening in the forefront of the nuclear field for the people to get informed on that. So, except for some minor misunderstandings from Sabine's side, or maybe not explaining it the way that perhaps I would, everything else was quite interesting and very informative, even for me as well. Let me know what you think about this video down in the comments, and if you want me to react to any other videos of a nuclear related context, don't forget to like and subscribe and click on the bell notification icon. It's been Elina, your friendly nuclear physicist, and until next time, see you soon. And produce electricity.